welcome back. More cracking the cryptic. Ugh. More cracking the cryptic. Sudoku. I want to do another one. So I guess whenever I'm doing one now, we're filming it. I'm standing. Benefits of a standing desk. Um, yeah, I'm gonna get back into this. I believe we're up to. Let me check. We're up to episode puzzle number 8, which is 500 factorial, no, 500, 500, 500, 500, which looks very interesting. Um, from what I just had a brief skim. There is 10 rules which are in place. 11 if you count classic. So there'll be a little bit of explaining to go through at the start. This will take me ages to complete. So if you just one of those things to have on in the background if you are watching. Okay, we'll run through the rules and then we'll get started. Classic Sudoku, I'm just not going to mention it anymore. The sandwich Sudoku, which I took notes, we did in number 5 and number 7, where the numbers outside each row and column must correspond to the sum of the numbers between 1 and 9 in that column. So let's say for this 5, the numbers in between 1, that's not a 1, 1 and 9 must sum to 5, which in this case would be a 2 and a 3. How do I get rid of these? There we go. Oh, it's been a while since I've done this. Same with the 0, which means the 1 and 9 obviously have to be next to each other because, yep, because if you have a space, that number won't sum to 0. Anyway, we've seen that before in episodes 5 and 7, so that should be familiar. The thermometer, which we have seen before as well in episodes 1 and 6, which is this grey thing over here, which means the numbers must increase as they move along the thermometers, starting at the bulb. So this number has to be lower than that, which has to be lower than that, which has to be lower than that, and around. So obviously there's a few properties about that which we already know, but we'll get to that later when we're solving. Yep. The killer Sudoku, which we have seen in episode 2, which is this middle box with the 35 in it. The cells in each cage must sum up to the number in the top left. So these 6 digits have to sum to 35. That's pretty simple. Seen it before in episode 2. Even and odd, this is a new one, but very simple. Cells containing a square, which is these 2, must be even, and cells containing a circle, which is these 4, must be odd. Very simple. Min and max is also, it's decently simple, which is these 6 cells here, which is a cell with 4 arrows pointing in, so that would be this one, and this one, those 4, must be smaller than all of its neighbours. So let's say for this one, for example, this cell, this cell, this cell, this cell, all of these pink cells must be larger than that blue cell. And that's the same for this blue cell, not that blue cell, and this blue cell. And the same for the pink. Let me just do this quickly. Where a cell with 4 arrows pointing outwards, here in the pink, must be larger than all of its neighbours. So all these 4 must be lower than this pink cell in the middle. So not simple, but also not complicated. The partial Kropki, which we have semi-seen before in episode 3, where a white dot indicates consecutive digits. So this could be a 4 and a 5, a 7 and an 8, but it can't be a 3 and a 1. And black dots indicate a multiplication factor of 2. So if this is a 2, this has to either be a 4 or a 1, because 2 times 2 is 4, and 1 times 2 is 2. This is why you tune in, you learn some stuff. But this is different to the one we did before in episode 3 because it's only partial, which means not all white and black dots are given. So these 2 could still be consecutive, these 2 could be consecutive, or whatever. Now some 3 new ones. I feel like we didn't go over this one, which we have missed. Yeah, the arrow, which we missed. The numbers along the shaft of an arrow must sum to the number at the base. So these 3 digits must sum to this, sum addition. And so these 2 must also sum to that digit. Okay, which I think we might have seen before, but if not, very simple. Now these last 3, the new ones, the tricky ones, the one that will need to get my head around. Oh, that's sick. The puzzle's called 500, 500, 500, 500 because at the top here, you've got 500. And then these are all meant to be 5s along the left, and these are all 0s in the next 2 columns. So there's 4 500s in a row. Of course, you know, these guys know what they're doing when they're making names. Anyway, German Whispers, which is this green. We might have done this. I do remember doing this. Maybe we do this for the special one. I don't remember. I've definitely seen this before somewhere. It is adjacent digits along a green line must differ by at least 5. So let's say this is a 2. These 2 here have to differ by at least 5, which means it can't be 3, it can't be 4, it can't be 5, it can't be 6, it can't be 7. So these 2 would then have to be an 8 and a 9. And that continues around. So this, let's say this one is the 8. This one has to differ by at least 5. So 8 goes, can't be 7, can't be 6. Well, obviously can't be higher than 8, because let's just agree on that, so I don't have to try and explain that. So it can't be 7, can't be 6, can't be 5, can't be 4, can't be 3. So only 2 it could be, 2 and a 1. Given there's already 2 in a box, that would have to be a 1. So that is complicated, but you know, gettable in the mind. I will, whenever I'm solving something, hopefully refer to what clue it is. And the clue should be in the description if you want to go and read it, so you can further understand. Entropic lines. Any group of 3 consecutive digits along an orange line must include 1 low, 1 medium, and 1 high digit. Right, so they say these 3 are consecutive along an orange line and must include 1 low, 1 medium, and 1 high digit. So if this is low and this is medium, that has to be high, okay. Which means basically those 2 are the same, they're either both low, both medium, or both high. Because then if those 3 contain 1 of each set, that means these 3 contain 1 of each set, and these 2 are the same, so these 2 would have to be the same. Which we'll mark as soon as we start the puzzle. And the last one, Renban, which I'm assuming is this purple one, which we have not touched yet. Digits along a purple line must form a consecutive group, but they may appear in any order along the line. Right, so let's say these are the digits 1 to 6. They are a consecutive group, but they can appear in any line and any order, so it could go like this. But given that all 6 of those are consecutive when put in a group, it works. Where this 3, if this 3 was, let's say, a 7, that would not work because these digits are not consecutive as a group of 6. I hope that makes sense. Okay, cool. So, there's a few little things about everything which I've noticed, but we are going to get started. So, first thing, this, did I notice anything about this? Well, 3 and a 2 have to sum to the same digit. Cool, not much given. This one, I believe, is our thermometer, where numbers must increase. So the lowest this number can be is a 1. So let's figure out the highest it can be. This would have to be a 9, 8, 7, 6, 5, 4. So this has to be 4 and lower, which means this one likewise has to be 6 or higher. And those numbers can fit in the middle. And these, the Renban, so a set of 6 consecutive digits, as we did before, can either be, that's the lowest set it could be, and the highest set it could be will be that. 9, 8, 7, 6, 5, 4. And both of these sets have 4, 5, and 6. So, that means that 4, 5, and 6 has to be on this purple line at some point. And you can either get a mixture of whatever. The green, which is a German whisper. Adjacent digits must differ by at least 5. The special rule with these, which I've done before, a 5 cannot appear on a German whisper, because if I've put a 5, that's annoying. This digit has to differ by at least 5, so it has to be a 0 or a 10. And both of those digits are invalid in a Sudoku. Which is pretty, I mean, that we've got a 5, kind of. These ones, we are going to label these high and low. So high temperature, we associate that with red, even, I think I talked about this with the flame anyway. And blue, associate with low, so we'll do that. So given this is a low digit, the smallest it can be is a 5 and lower. Because these 4 have to be high, which means it would have to be 7, 8, 9, 6, 7, 8, 9. Same with the blue, it has to be a 5 or higher. So these could have to be a 1, 2, 3 and a 4 if it was a 5. And those are the same for all reds and blues in there. But if this is a 9, this can still be an 8, so that's why that's not red. Doesn't work like that. Yeah, not much else appearing to me here. This we know has to be a 1, 2, 4, 8, because this can't have 3 or 6 in it, because then another double cannot be found. So this has to be a 1 or an 8. Say this is a 1, this can be a 2, and this can be a 4. So if this is a 2, this can be a 4, and this can be an 8. And same way, this could also be a 1 here, this could be a 2, this could be a 4, this could be a 2, this could be a 4, this could be an 8. So basically, those are the only digits that could ever go there. And I believe this makes this a 3, 6. So if we'll have 3 of the digits 1, 2, 4, and 8 up here, which means there's no other way we can make a double. I've gone through this idea in the Kropki one, where the only doubles possible are 1 and 2, 2 and 4, 3 and 6, and 4 and 8. And given that 1, 2, 4, and 8, 3 of them will be here, let's say it's 1, 2, 4, the only digits we have left that can be in that double pairs are 3, 6, and 8, which means this bottom one has to be 3, 6, and 8. And the adjacent digits to 3, 6, and 8 are 2 and 4, because this white means it's adjacent. So if this is a 3, this has to be a 2. And if this is this can't be a 6 now, because none of these digits are adjacent to a 6. So we actually get to place a 3 there, a 6 there. This now has to be a 2 or a 4, which means this is the opposite of 2 or a 4. Which means this can't be a 2 or a 4. So it either goes 2, 4, 8, or 4, 2, 1. But this is consecutive now. So given that these 3 are consecutive, if we want this to be a 1, we'd have to get 1 consecutive to a digit consecutive to 6, which is not possible. But we can get 6 consecutive to 7, which is consecutive to 8. Like this, 8, 4 times 8 is 2. 4 times 2 is 8, and 2 times 2 is 4, which means these digits are 5, 7, and 9, which we could have... Nope, that is incorrect. 5, 7, and 1. 1, 5, 9. And we don't know much about those digits at yet. It's a pretty good start. I feel like this box is nice and saluted. That's also not a word. What am I? Saluted? This one here is our entropic line. Right, with our, let's say these are our low numbers. Or no, these are in sets. Orange and pink. So if pink is a low, digits 1 to 3, then pink would also have to be a low 1, 2, 3. Yeah, so if let's say green is whichever one, either low, medium, or high, that means the other green one has to be the same. Which makes a lot of sense. Evens. Okay, I jumped ahead. In this bottom row, you know, there's 4 evens between and including 1 and 9, which is 2, 4, 6, and 8. Look at me go. We've already got 2 evens here. We know these 2 have to be even, which means these are the 2 and the 4. Which is nice. That's objectively nice. Which means our 2 and our 4 do not go on this line. They have to be over here. You know, by simple Sudoku, you know, that once concept that seems so ridiculous now. We do have 4 odds here. We do have 2 evens here. So that means 8 and 6 have to be on this side. Okay. Oh no, they could be over here. But what I'm seeing here is this 6 and this 7. They're both in the same... No, they're not. This 7 and 8 are both in the high set, 7, 8, and 9. Which means one of them must appear over here. Because let's say... Because the 7 and 8 obviously can't go here. Say if this is the 7, this has to be the 9. And if this is the 8, this has to be the 9. Same thing, if this is 7, this is 9. If this is 8, this is 9. If this is 7, this is 9. If this is 8, this is 9. So that means this either here has to be a 7 or 8. Which means our 9 in this box has to go here and then here in this box. Which makes sense because it's on an odd digit circle. Cool. I'm assuming I can use the same logic for the 2 and the 3. Actually, because the 2 is already over there. That makes sense. Which means... No, that doesn't tell us anything. Else could, you know, you get hopeful. Oh, but that tells us the 3 is not over here. Does that mean the 3 is here? Okay, let's focus. The 2 and 4 are guaranteed here. And then it's either a 7 or an 8, which means the 3 has to be in one of these, which means the 3 is in one of these. Okay, we're getting places. And the same rule with this... Not the same. The 7. Now in this bottom box. Yeah. So since there's 5 odd digits between 1 and 9. 1, 3, 5, 7, and 9. And we've got 1 odd here. These 4 must be the other 4 odds. And this can't be a 7. So the 7 has to go over there. Sick. I don't think I know anything else about any of these. Okay, maybe we give thought to this killer cage. Let's see, it's usually a helpful sum. So now we know that 5 goes here, which means a 5 doesn't go there, which means there 100% is a 5 in this box. Which means it can't be these top 2. Now what these 2 think, this is cheating. Not, I wouldn't say cheating. Mathematical aid. Which means these 2 must have a 5 in it. By this they also must have a 4, and they must have an 8, and must have a 9. And they don't. What numbers do they not have? They've got, neither of them have a 1. But that's the only number they both do not have, which means we know there's a 1 over here. This, the other 2 digits in here could either be a 3 and a 6, or a 2 and a 7. Cool. Very cool. No, yeah, we know 1 goes there and a 5 goes there. Let's actually just move that 1 from the middle and put on the top left. Okay. This 1 being out here means it can't go here, which means it has to be on one of these. And same with a 5 has to be here somewhere. But we don't know where yet. Okay, we can actually gain more information. This 0 in the middle. Oh, I can still go on the Ren band. 1 goes 9 and 9 can, so 9 can't go there. or there. Because of this thing, the machine's 1 and the 0 at the top. Oh my god. Whoa. Yeah, let's get these up. Given that the 0 here means the 1 and the 9 are consecutive digits. Which means the 1 and 9 has to be next to each other. Given the only place the 1 can go in this box is here, which means the 9 can be either side of it, which is fine. And that can't be a 9, obviously, because the 1 can't go there or there. But these 3 can still all be 1s and 9s at the top. If there's a way we can remove 8 from here, that would tell us a bit. Actually, no, this can't be a 4. Actually, it can be. Oh, have I got these arrows the right way round? Arrow, the numbers, nope, wrong arrow. What arrows? Min and max. A cell with 4 arrows pointing in must be smaller than all of its neighbours. Okay, I've got these the wrong way round, actually, so take back everything I said. Just tidy this up. So that must be smaller, so it's blue. Yeah, I guess that makes sense. So this has to be 1, 2, 3, 4, 5. Okay. And this must be the larger value, which is 5, 6, 7, 8, 9. Okay, given the 1 thing, that's okay. That means the 9 can't go there, because the 1 can still go there or there. So, what I was going to say, given that this has to be bigger, yeah, that makes sense. Given this has to be smaller than this, that can't be a 9. That's what I gathered. It'd be nice if that was a 5, because it would tell us a lot about these. Or this was a 5. If one of those was a 5, that would help us a lot. Okay, I've just seen something, thing about the Sudoku sandwiches. There's lots of ways, there's lots of different things that you're probably, mind's going off that I could do. That's why it's so confusing. The 0 up here means that the 1 and 9 must be consecutive. And we know that there must be a 9 here, which means the 1 has to be in one of these. And the 1 has to be the low digit on this entropic line. Any group of 3 consecutive digits along orange line must include 1 low and 1 medium. So this digit here, actually no, that doesn't make sense, because this could be the low. No, it can't, because the low has to be a 1 or 2 or 3. And it can't be a 2 or 3, which means it has to be a 1. And if we put a 1 down here, there is no digit 1, 2 or 3 we could put here, which means that is the 1. And that is the 9, because those two must have a 0 sum. Given these are both low now, that has to be the 3. I hope that all made sense, because my mind cannot redo that, and I hope it's right. That makes sense. My logic is always flawless. Okay, where to now? No, these must be medium and high. 7 and 8 are both high, which means there has to be one of those to be a 9. What digits do we need? Okay, now the 1 has to go down here by Sudoku, which means this is a 5, 7. So this will tell us about the nature of this. So this has to be now a 6. 4, 5, 6. Yep, so for the middle digit, this has to be, yeah, so it can't be a 4 or a 5 for the middle digit, so it has to be a 6. And for this, I've seen these two 7s here. This is now 7s, which means the 7 has to go over here. Which means the 8 has to go here. Yes, this has to be a 6-8 pair. And the only digit left that can go with the 9. And it has to be 1, 2, 3, 4, a 5. Which makes sense, because that means it would be in the middle group with the 6. Okay. So if this is high, this is high. If this is middle, this is middle. Or if this is middle, this is middle. This is high, this is high. Cool. And then the bottom, now we know what these three are. These three are 3, 5, nope, not 5, 8, and 6. Cool, this right side's looking really nice. I'm scared to go touch this left side though, because it is looking rather messy. I'm actually going to change these to these markings. Wait, not those. There we go. Okay, I'm thinking about this. This is the German whisper, which means things much stiffer by at least 5. Let's say we've got the digit 4 in here, right? The only digit that is different by at least 5 is a 9. Alright? Because it'll be 9 and above. That then means over here, this digit has to also differ by at least 5. So it has to be either a 9, a 0, or a 10. Which is impossible because it would have two 9s in the same row and box. Which means this digit can't be a 4. So there can't be a 4 also on this German whisper. Which means the 4 has to go out here. Out here. Oh my lord. Massive voice crack back then. Tried to replicate. With the 5 out here as well. And I think the same is going to be true for the 6. Because the only one that's different is a 1. Which means this would have to either be a 1 up here or a 10. Both, once again, which we've established, 1, 10 or 0, which we have established is not possible. Okay. Okay, that tells us there must be a 6 inside this middle thing. So it has to be with the 3 and the 6. Which means our numbers outside our are 1s, our 2s, and our 7s. Where this one can't be a 1. And that... This is really, you know, testing my brain power. If I could solve these, this would help a lot. So that has to be smaller. Yeah, that can be a 3, so that can be a 2. Now, given that this, why can't this be a 9? Yeah, so this can't be an 8 now, because this is a 9 over here, so this can't be a 9, which means the highest this can be is an 8. Have to be bigger than that. Okay. Sneakily, we know that the one can't go in any of those cells. Actually, I could go there. I completely lied. I'm thinking about this 5. So the 5 sum between the 1 and the 9 for this sandwich clue can either be a 5 by itself or a 2 and a 3. Which means nothing at the moment. Let's talk about, let's debate this up here, which is our arrows. The numbers along the shaft of each arrow must sum to the number at the base. Let's think about the lowest possible these three could sum to, which would be a 1, a 2, and a 3, which means this would be a 6. But then this is 1, 2, and 3, which means this has to be 4 and 5, which means that would be a 9. Ew. And that wouldn't work. So this is probably some algebra equation. Let's say this is 2, 3, 4. What does that sum to? 9. So that's the highest this could be. This actually has to be the digits 1, 2, 3, and 4. Because if it's the highest 2, 3, 4, that will have to be 9 over there. And we know 2 can't go there, and 3 can't go there. And these don't depend on order, by the way, so I don't have to make this consecutive or whatever. Which means now the lowest, this can be a 1, 2, a 3, 2, 1. Yes, this has to be a 6, 7, 8, 9. But it can't be a 7. Which means the combinations of 1, 2... No. Yeah, 1, 2, 4 would not work. Which means this has to be the 3. Because if this wasn't a 3, the only digits we can place are 1, 2, and 4, and 1 plus 2 plus 4 is 7. And this can't be a 7 because of this Sudoku over here. So this has to be the 3. And the lowest we can make is still a 6. But we could make also 8. And we could also make 9 still. So now let's think about this top. The digits we can use are the digits 1, 2, 4, and 5. But we can't use 4 because it is over here. Which means 4 has to be down here now. Because if we put a 6 anywhere on here, we are screwed. If we put 6, 1, we can't do 6, 2 actually. No, but then this can't get down low enough. So there is a 1 or a 2 up here. With a 5, which means this can't even get remotely near 9. Yeah, alright, 3 plus 4 has to be at least 7. So this can't be a 6. But it can be a 1 or a 2, which gets us to 8 or 9. This 5. 5 plus 2 is 7, which wouldn't work. Or 5 plus 1 is 6, which also doesn't work, which means the 5 can't go here. This can be high. This can be a 6 or a 7 now. Well, let's just put this 6 back and go back to 1, 2. We'll like this, right? Because those are the only digits that can go there. Right? This can still sum to 6. Completely perfectly. Oh wait, this can't be a 4. Because it's simple. Okay. Yeah, I completely agree with that still. Given that this has to sum to a maximum of 9, you can't use 8, because 8's already here. We can have a 7 and a 2 and a 1, because it can be lower. We can have a 6, a 2, it's for 8. And we can have a 5 and a 1 for 6. Okay. However, if a 1 is here, that means a 5 and a 1 up here we can't do. So if this is 1 and 2 to sum to 6, we actually can't get this to 6. Because to get this to 6 we need a 1 down here, and to get this to 6 we need a 1 up here. Or we could go 2, 4 up here, actually. No, we can't go 4. Yeah, so this can't be a 6. And to get this to sum to 8 or 9, we can't get this to 8. Because we need 2 odds, which is 3 and the 1, plus the 4 is 8. So we can get it to 8, actually. Huh. But we have to have the 4 down here. Yeah, this is where I was. We have to have the 4 down here. Which means this is either 8 or 9, where this is a 1 or a 2. And now this can't be a 5, because that means to get to 8 we need a 5 and a 3, which is not possible, or a 5 and a 4. So that can't be a 5. Which means the 5 is out here. And the 9 is out here. No, it's not. Get over it. Okay. Let's think about how we get 8 over here. A 6 and a 2. Which would be possible, because then we would have a 1 and a 4 down here. That works. That works. Can we get 8, 7 and 1 up here? And then 1 and 4 would have to go down here. So it would have to be a 7 and a 1 up here, or a 1 and a 4 down here. So if we're going for 8, we have to use the 2 and the 6 up there. Yeah. If we're going for the 9, we have to use the 2 and the 7. And then the 4 and the 2 down here. So what I'm hearing, that has to be the 8. Okay. To get this bottom one to 8, it has to be a 3, a 4, and a 1. So the 4 and the 1 are used down here. To get this to 8, we can't use the 7 and 1 because the 1's already down here, so this has to be the 2 and the 6. Cool, that makes 8 work. For this to be 9, this has to be the 2 and the 4. Which means we can't use the 2 up here. Which means this is impossible. So this has to be the 8. How do we say we make 8? With 3, 4, and 1. And how are we making 8 up here without the 1 and the 7? The 2 and the 6. Which means the 9's over here, and so is the 7. Sick. I believe that all works. And this tells us a lot about this thermometer. Because this means the 9 can't go there, which means the 9 must be on the thermometer, and 9 is the highest digit. So that tells us that. It's a 9. Oh no, we don't know that's an 8 yet. Ooh, ew, what am I doing? Put the 8's back here. But we know the 8 can't go there, because of the same thing as before. If that's an 8, which is the highest it can be, that has to be smaller. Which means these can all still be any number, basically. Should I put them in? Okay. That can be 8, 7, 6. Let's just do 3s right now. 7, 6, 5. 6, 5, 4. 5, 4, 3. 4, 3, 2, 1. Yep. Okay, cool. So this can be 9, 6, 5, 4, 3, 2. No, this can be lowest. This can be 9, 5, 4, 3, 2, 1. This can't be the 3 because of this. Okay, this is progress. Okay, this 2 and a 6 is a pair now, so this can't be the 2 or the 6. Can't be the 4, so that is our 5. Which is helpful. It's actually helpful. Can I do the same with the 1 and the 4? Yes, I can. This cannot be a 4, which means this is our 6, and that means I've made a mistake. Which is not good. What do we say this was? The 4, 5, 6. I'm confident those have to be the 4, 5, 6. See, that would be the 5. That would have to be the 5 as well, for what I've done. I'm pretty confident in this. Which means this is probably wrong. So given that there's a 4 and a 6 here, these two both have to be 5s. Okay, time back to the drawing board. Let me just remove all this. I believe what we were doing was right. I mean, if this is wrong, I mean, we just give up at that point, right? Let's think about this. Again, the highest these three digits can be 2, 3, 4. Because 2 plus 3 is 5, plus 4 is 9. So these have to be any digit 4 or lower. Which means the lowest this can be is 1, 2, 1, 2, and a 3, which is 6. Okay, we know this can't be the 2. We know these can't be the 3. And we know this can't be the 7. Which means we know that has to be the 3, right? Because 1, 2, and 4 add up to 7. And if that is a 1 or a 4, this means this has to be the 2 and the 1 or the 4. So this has to be the 3. Okay. Hopefully this doesn't break right now. This cannot be the 6. Because if this is the 2 and the 1, this would have to be either the 4 and the 2, or the 5 and the 1. Which are both not possible, because the 2 would have to be used here, and the 1 would have to be used here. So that can't be the 6. This is feeling like it has to be 9 now. Oh, because you can make 9 with 8 and 1. Oh, I can't use 8 though. Am I reading this right? Arrow. The numbers along the shaft of each arrow must sum to the number at the base. Sum is addition. Oh, I keep tripping right now. 4 plus 2 plus 1 is 6, and that cannot happen. 3 plus 1 plus 4 is 8. And if we have an 8 here, the ways we can make 8 are 1 and 7. Which we can't do because 1's here. It's 2 and 6. Which we could do, which is what we had, I believe, with a 1 and a 4 down here. It is 3 and 5, which we can't do because there's a 3 there. And it's 4 and 4, which we obviously can't do because it's Sudoku. And we've established this has to have a 4. Which means if that's a 4, this is a 5. But we're not going to do that because we know this is ropes. Let's put the 5 back here, and so that would have to be a 5. Given there's a 4 there. Which means this has to be either 8 or 9. And can we make a 9 here without a 1, a 4, or a 2? Yes, we can. With the 1 and 8. But that doesn't work with this 8. So I believe this is wrong somehow. Because this cannot happen. Unless that isn't the 3. It has to be. Because if that's the 4, 3 can't go down here. One, 2, 4. That doesn't work. 8. No, conjective. This is all right. Don't know why this isn't working. 4. What about a 3, 6, 1 or a 3, 5, 1, Ollie? Why 3 plus 6, 3, 5, 1 works? 3, 5, 1 has to be it then. Because 3 plus 5 plus 1, or 3, 5, 2. So the 4 doesn't have to be there. The 4 actually doesn't work there. We've established the 4 can't go there now, I believe. Why didn't I think 5 could go here before? 2, 3, 4. Because I could go, I just wasted 40 minutes of my life. Not quite. Okay, let's say there is a guaranteed 5 now here. Which means this has to be the 4 in here. Okay, let's hope this works now. So 3, 5, 1 gets us to 9. Which means this would have to add up to 9. Which we can now use the 2 and the 7. That would work. That would work. That would work. And that means we could still get our 5 or our 6 in here. It's not going to break on us. If this is a 3, 5, 1, which adds up to 9, which means this can't be a 2 now. Does that just work for us? These both add up to 9, which put a 9 there. And this can leave this open, put a 4 there. I believe I'm willing to say that that works. After a moment of me being an absolute imbecile. That's a bad word. That's a bad word. No. Okay, 5, 6, this has to be a 4. Which means that's a 4 by Sudoku. And these numbers outside have to be our 8 and our 6. Our 5, our 6. That can't be a 6, that has to be the 8 there. Our 6 goes in here. Puts our 5 there. And our 6 there. Okay, that all works. It hasn't broken, which means I believe we're in the money here. Oh no, it has broken. Because the 5 in this row doesn't go anywhere now. Oh, it has to go there. Ah. Okay. We're back. Let's focus, Ollie. Okay. Which means these numbers in here have to be our 1 and our 8. Hello. Welcome back. This is voiceover Ollie. I believe this is the second time I'm making an appearance. I have cut the next 15 minutes worth of me solving this problem due to the fact that I went 15 minutes rambling about who knows what, trying to figure out what I have just figured out. As you're seeing this, I've figured it out correctly. Everything you've seen on screen, everything I've talked about has been correct. Except I convinced myself that on the German whisper, the 8 has to be next to a 2 or a 1. However, it can be next to a 2, a 1, or a 3. So now I spent the next 15 minutes torturing myself, trying to figure out other combinations to make that left arrow work. Spoiler, there was none. So eventually I circled round back to this combination, and it did work, and I, pulled my head out of my arse and realised that, the 3 could be next to the 8. And, yeah, so I've wasted 15 minutes of my own time, but I don't quite feel like wasting 15 minutes of yours. So I'm going to put you right where I start to figure out, again, what the correct combination is. Cheers. 1, 5, 8. And the 5 can't go anywhere here. Can 8 be next to a 3? Can 8 be next to a 3? Yes, the 8 can be next to a 3, you imbecile. 9 can only be next to a 4. A 9 can be next to a 4. Which means an 8 can be next to a 3. Oh my. I was here. I don't know, I'll check the time. I'll put the time right ahead. I might even just cut that whole bit. I'll tell you to skip forward to the here, and I'll put the time up here. So I'll tell you how long I spent in a circle achieving nowhere. So that's the 5. Okay, this is the 1 and the 8. Okay, we are back where we were 20 minutes ago. Oh Lord, have mercy. The 8 has to be now, has to be around a 2 and a 3, like this. Given the 2, it can't be up here. That has to be a 3 up there and a 2 down here. Pretty simple for the 8. If the 8's there, that has to be a 3, that has to be a 2. That is the most simple thing I've done all evening. Hopefully. What did we say with this was? This has to be those numbers. Let me just whack these back in, because they probably got removed while I was having massive brain farts up above. This is obviously not simple. So that can't be, these two can't be 3 now. 3 can't go down here. That can't be a 9. Which means that can't be an 8. That can't be a 7. That can't be a 6. That can't be a 5. And that can't be a 4. Cool. Actually, we know this can be, there has to be a 6 down here still. Okay, this tells us that there has to be an 8 on this. Because there has to be the 8. Which tells us over here that this is the 5. Which means the green, because this is our thing down here, entropic line. Which means our green is our medium digits, which is 4, 5, 6. Which this has to be our 6 up here. Which means this is our 8 in here and our 9 in here, through the same logic. Okay. This can still be 7. This can still be 6. This can still be 5. This can still be 4. This can still be 2. Cool. Okay. This one, we remember, was consecutive digits. Right? In any order. This row needs a 9 in it, and it can't go in the top box, it can't go in the middle box, so it means it has to go right here, which means this is our digits for the set 4, 5, 6, 7, 8, 9. So let me just whack all those in. And the 9 can't go there. We know the 9 can't go there. We know the 8 can't go there, because Sudoku. No, the 9 can't go there because of this. Because this is our 1, 2, 3 out here. But that's not a 1. This will be very interesting how this interacts. This can't be a 1. Because that would mean that would have to be bigger. 1 would have to be bigger than a number, which is not possible. Because that's our 1 in here. Okay, this is just kind of going in a circle when using everything. Given that that's a 1, this can't be a 1, which means this can no longer be a 9, because remember, in this column, the 1 and the 9 have to be consecutive. So if the 1 can't be there, and the 1 can't be there, that means this can't be a 9. We can also place the 1 down here, given that the 1 can't go in any of those. We know there's a 1 guaranteed in here, like this, and that can't be a 1. Because it has to be bigger than digits. So means that's our 1 down here. Puts an 8 up there, because this has to be 1 8 pair. We said the 8 has to have a 2 and a 3 around it, and the 2 can't go up here, so that's the 3, that's the 2, that's the 1. And we know the 1 has to be next to a 9. And our other digit up here is a 7. Like that. To fill this box correctly, and the 7 can't go up here, so that's the 9, which satisfies the Sudoku. The That's our 7. That puts a 1 here and a 9 here. This is actually working. I'm actually solving something, rather than playing around with numbers up here for 20 minutes. God damn. Okay. I mean, that is bigger than that. We don't know these numbers outside yet. I think this is where we'd have to go next. Now let's look in here. 5s can only go there, up here. This can only be a 4 or 6. This is a bigger than. That's a 4, that can still be anything. That can still be a 5. The 5 can't go here. That doesn't tell us anything. That can still just be a 5. Ooh, actually, we have to have an 8 and a 9 down here. 8 and a 9 down here. Doesn't work. Oh, yes, right, because the 9, okay. Where's the 9 in this row, column going? It can't go there, so the 9 has to go down here somewhere. Which makes sense, that makes us an X-wing, like I like to call. And no digit can be bigger than a 9, so the 9 can't go there. Because this is our 9. Which means these two digits have to be our 8 and our 3 to finish this column. And now this can only be a max of 8, which means this cannot be the 8. Which means this is our 3, and this is our 8. This 3 removes a 3 from here. That's our 2, that's our 3. And, I don't know, yeah, this 2 over here, remove this as a 4. 4, 2. This 6 was a 6, 8, 3, with 8 and a 3 being here now. There's an 8 there, and a 3 there. Okay, this is getting there. Yeah, that means that's a 9 over here, actually. Yep, that's a good point. Yeah, where can 2 go in this row now? That's the only spot a 2 can go. Cool. We'll whack that in there. This is for now 5, 6, 7. This can either be a 4 or a 5 still. Okay, now where is 4 going in the box? Because 4 can't be bigger than 4 numbers. Actually, 4 could be right here. Do you know this can't be a 3 or 2 or 1? Yeah, so this has to be our 4 in here. Okay, this is basically solved. I just need to not be an idiot for 20 minutes in a row, and we will get there. 5, 7, this can't be our 6. Oh no, it can't be a 6, what am I talking about? Yep, that was what you're trying not to be, Ollie, an absolute idiot. Okay, that has to be an 8. Because this and this, yes, that has to be our 8, over here. 4, 5, 7 in here, and 4, 5, 6, 7. This is all working, this is all less and greater than. One, 2, 3, 4, 6. Okay, well, let's actually look at this box. A 3 has to go in there. Makes a lot of sense. 4 has to go there. Makes a lot of sense. The 6 is to go there. Okay. The 8 can only go there because you got this 8 going there, this 8 going there, this 8 going there. Yeah, okay, that's our 8. Now 3 only can go there. Does this lead our 9? I'm assuming is the same. 9 can't go there. 9 can't go there because this one. And why can't 9 go there? Because it has to be bigger than that. Yeah, right. So that is our 9 up here. Okay, where's 5 going in this row now? Has to be there, because it can't be there. We've established that for a variety of reasons, what I've figured out. I'm just going to trust myself. Back my gut. Like I haven't been doing. So that's our 5. These two 9s mean these can't be 9s, which means this is our 9. And to fill out this column, we need a lovely 7. Which puts us a 6 in here, a 4 in here, a 3, a 2, and a 1. We'll just hopefully this puzzle just breaks so we can just fill in everything. Oh, nope, that's a 2, that's a 1, that's a 3, that's a 4. This 2, that's 7. 2, this 5, I'm assuming was this 1 here, yep. 7 here. Yep, this 7 makes this a 5, because this has to be bigger. That makes that a 6, makes that a 7. Makes that a 4. Hey, a 4, a 5, a 6 in there, a 5 there, and a 6 there. And a 7 here, and a 5 here. Oh my lord. Jeez, I made a mess of that. Yeah. If that was confusing for me, I'm sure that was even more confusing for you guys. I reckon without that 20-minute absolute brain fart, that would have been fine. Yes, I did just spend 18 minutes straight solving one single Sudoku. But in the end, I enjoyed it, so that's all that matters. We'll do twisting arrows whenever I feel like it. Oh no, we're not twisting arrows. We're up to puzzle number 9. What a cool name. We'll do that whenever I feel like it, which looks cool. Yep. Peace.